Sequences and series. Test question or exam question. Question 1, 1.1. Given the sequence -2, p, -8, and so on and so on. Determine the value or values of p if the sequence is 1.1.1 arithmetic. Determine the values of p if the sequence is arithmetic. 1.1.2, we are still going to determine the value or values of p, but now if the sequence is geometric. Now, we're at 1.1, and the sequence, remember, it's -2, p, -8, and so forth, and so on and so forth. How do you know that a sequence is arithmetic? It's when the first difference is common. When you have the first common difference, your first difference is common, it's equal, it's the same, meaning T2 term 2 minus term 1 is the same as term 3 minus term 2, the same as term 4 minus term 3. So it means that T2 minus T1 must be equal to T3 minus T2. So that we're going to say T2, remember, minus T1 must be equal to T3 minus T2. Which would then, what is T2? What is T2? T2 is P minus T1. T1 is -2, so it's minus 2 equals to T3, which is -8, minus T2, which is just P. That, of course, an enemy of an enemy is a friend. -8 minus P. That would mean if I take P to the other side, I would be having a 2p, because when you take the p to the other side, it becomes positive. There'll be a 2p. And when you take the 2 to the other side, it's going to be a -2. So it's going to be a -8, -2, -8 minus 2 is going to give you what? It's going to give you a -10. Dividing both sides by 2. Thank you. You get P to be -5. That is 1.1.1. You have determined the values of P 1.1.1 when the sequence is arithmetic. 1.1.2 says determine the value of values of P if the sequence is geometric. It's the same sequence -2p and -8. When the sequence is geometric, 1.1.2, what does that mean? It means that the common ratio, the ratio must be common. The ratio must be common. There is a common ratio, meaning T2 over T1 is the same as T3 over T2 is the same as T4 over T3, and so on and so on. So the common ratio is equal, meaning T2 over T1 must be equal to T3 over T2, which then gives birth to you substituting what is T2. Remember what is T2? T2 is P. T1 is -2. T3 is -8. So that's going to be P over minus 2 is equals to what? Is equals to what? Talk to me. It's minus 8, which is T3 over P. In this particular instance, there's one term, so you cross multiply because there's an equal sign. When you cross multiply, get P squared, and minus 2 times minus 8 is equals to 16. An enemy of an enemy is a friend. When you put a square root there on both sides, you realize that P is plus minus 4. So P is 4 or P is minus 4. Another person could have written it to say P is 4 or P is minus 4 or negative 4. It doesn't matter really. Because another person could have used the fact that when you take the minus 16 to the other side is the difference of two squares. Another person could have done that. And that's how you answer that particular question. Now, let us go to 1.2. 1.2. Consider the growth of a plant. In the first year, the plant grows 850 centimeters. In the first year, the plant grows 850 centimeters and continues to grow by 3/5 of the previous year's growth height. 3/5. 3/5. 3 over 5. 3/5. The growth of the plant at the end of each year forms the terms in a number sequence. Write down the first 3 terms, 1.2.1. The first term grows. The first growth in the first year is 850. That is 1.2, and we are at specifically 1.2.1. 1.2.1. The first term is 850, the first growth. It's 850. They say this follows a pattern. This forms terms in a number sequence. The second growth is 3/5. So it's going to be the first growth in the first term, and the second term will be 3/5. That is the second term. That is the growth. And then they want the first 3 terms. So the first term grows by 3/5. The second term must grow by 3/5. So what is the second term? It's 850, 3/5. The second term must grow by 3/5. Got that? The second term must grow by that. When you go on to your calculator, of course the first term will be 850. The second term, if you put this on your calculator, 850 multiplied by 3 over 5, that should be 510. And that 510, this particular thing, when you put it in a calculator, it should give you a 306. That 510 multiplied by 3/5 must give you a 306. And those are the first 3 terms as per the requirement of that particular question. 1.2.2 show that a convergent geometric series is formed. Convergent. show that a convergent geometric series is formed. Firstly, being a geometric series, there must be a common ratio, or rather a constant ratio. How do you know that series is convergent? The ratio must lie between -1 and 1. Firstly, you can see from here that, R, that is 1.2.2, R, you can just say R is actually 3 over 5. You can read it from there because you can see that your R is 3 over 5 because this is 510, this already, it's 510 multiplied by 3 over 5. But if maybe you are not sure, you are panicking and all of that, you are being told it's a common ratio. It's a geometric series. It's a geometric sequence. So you don't have to prove that T2 over T1 is equal to... No, you don't have to prove. You can just use the fact that T2 over T1 is R because you are being told it's a geometric sequence. It forms a geometric sequence. So you can just write 3 over 5, or I would just say this is 510 over 850, which is actually 3 over 5, if you are panicking. If you are panicking. Therefore, they said, remember the question says, show that a convergent series is formed. Therefore, the series 3 over 5 is the same as 0.6. 0.6. The series is convergent since R lies between 1 and -1. That's it. That's it. The series is convergent. You're going to get a mark there, and you're going to get your mark there. You're going to get your mark there. The series is convergent because R lies between 1 and -1. This is 0.6. The ratio, the common ratio, the constant ratio must lie between -1 and 1. It must be greater than a -1, but less than a +1. And that's how you answer that particular question. 1.2.3. Determine the maximum height. Already we have proven that this series is convergent. When a series is convergent, when your ratio lies, your common ratio or constant ratio lies between -1 and 1, when a series is convergent, definitely the sum of that series approaches a certain value. So these heights, when you add them together, up to infinity, they are going to approach a certain value. What are you thinking of? Exactly. Sum to infinity. Sum to infinity. That's what 1.3 requires. Determine the maximum height. They are actually asking for the sum to infinity. 1.2.3. Already from the series, we know that A is 850. We have also confirmed that the constant ratio is 3 over 5. Sum to infinity, the formula is sum to infinity is equals to A over 1 minus R. Therefore, the sum to infinity, let's do the substitution now. A, which is 850, the first term. 1 minus 3 over 5. I expect you to put that in a calculator from here. I expect you to put it in a calculator. When you put it in a calculator, you realize we have 2,125 centimeters. That's the maximum height. That is the maximum height. That is the maximum height of which that plant can reach. Now let us go to 1.3. 1.3, determine the value of n for which the sum of minus k plus 3 from k equals to minus 2 to n minus the sum of 2k minus 4 from k equals to minus 2 to n is all equal to 0. So we want to determine the value of n for which this series, subtracting this series, they equal to 0. Now, in this type of situation, I would say find the first 3 terms of this series and find the first 3 terms of that series. Because remember, this series can be written in terms of Sn is equal to, remember that formula? Depending if this series is arithmetic or geometric. Also depending if this is arithmetic or geometric. Because this is actually Sn. It's a sum to n terms. Also, this one is the sum to n terms. Now, let us put this into practice. Let us put this into practice. The sum, that is 1.3. The sum up to n, the sigma from k is equals to minus 2 of minus k plus 3 is actually equal to, it's equal to, if you had to put that, your first term when k is minus 2, let's put that, when k is minus 2, it's going to be minus, when k is minus 2, it's minus 2, okay, plus 3. The first term is 5. Plus, this is a series. You just go there, you use the cursor from minus 2 going up, minus 2 minus 1. When k, because remember, it's when k is minus 2, k is minus 1, k is 0, 1, 2, 3, up to n. You remember that. So when k is minus 1, that gives you 4. We're just finding the first 3 terms. And you can work around the same method. When k is 0, that should give you a 3. Plus, going on and on. This would then actually, if you look at it, it is an arithmetic series of some sort. Can you see this arithmetic series where the a is 5, the first term? 4 minus 5 is 4 minus 5 is minus 1. 3 minus 4 is minus 1. So your d is minus 1. Remember, this is Sn. It's Sn. So what is it that you do not know is the value of n. Because this is Sn. This is the sum to n terms. This. Let us look into the other series, which is 2k, well, the sigma, or rather the sum of 2k minus 4 from k minus 2 up to n. Let's do that one. From k is equals to minus 2 up to n. That n must be visible there. Such that you've got 2k minus 4. Using your calculator, same method. Now in this instant, 2, we said from k minus 2. Minus 2, and then minus 4. Using the same method, we realize we have a minus 8. You can use the same method when k is minus 1. You'll realize that you are in fact getting a minus 6, and you'll also get a minus 4, going on and on. We just wanted the first 3 terms. You'll realize that here, ladies and gentlemen, a is equals to 5. D is equals to minus 6 minus minus 8, minus 4 minus minus 6. It's a positive 2. And actually, this is Sn. The thing that you do not know is n. What you don't know there is n. Since this is Sn, now let's put it in the Sn formula in a very lovely way. In a very lovely way, we can say this is n over 2, the first one. Remember the formula of Sn? 2a, 2, what is a? 5 plus 2a into n minus 1 multiplied by d. D is minus 1. All close. This is this. This is this. Remember, the instruction is that this sigma, this series must subtract this series, and they must equate 0. Subtract this series now. You realize this series, it can also be written in the form of n over 2 into 2a. What is a here? A is actually minus 8 for this one. A is actually minus 8. It's minus 8, that is the first term, plus into n minus 1, close into 2, all close equals to, because this subtract, remember, this minus this must equal to 0. So this minus this must equal to 0. This one is this, and this series is that in terms of Sn, equal to 0. Equal to 0. In this particular instant, we can have such that n over 2 into 2 times 5 is 10, minus 1 times that is minus, and minus 1 times minus 1 is 1, a positive 1 for that matter. It's a positive 1 minus n over 2 into 2 times minus 8, it's minus 16. 2 times the n is 2n. 2 times the minus 2 is the minus 2. Close, all equal to 0. Can you see now that everything is gone? We're just having the n, which we actually have to solve for. Now we are actually having the n that we have to solve for. In this particular instant, it's an equation. We can just multiply by the denominator, the LCD, which is 2. Also, the right-hand side will be 0. So we multiply 2 everywhere to get rid of the fraction so that we can have a flat equation. Multiply everything by 2. We have n into 11 minus n minus, we've multiplied by 2 everywhere, n into 2n minus 18. Are we together? All equal to 0. In this particular instant, you have 11, well, ladies and gentlemen, you have 11n minus n squared, because you distribute that, this is grade 12 mathematics. Actually, it's algebra from earlier, it's distribution method. Minus that times that will give us a minus 2n squared. A negative times a negative gives you a positive, which is 18n, equals to 0. Minus n squared minus 2n squared, it's actually minus 3n squared. 11n plus 18n gives you a 29n. Seems like there was a mistake with this particular question. Not in our answer. Not in our answer. A mistake was in the original question itself. In the original question itself. But it's fine. If the mistake is in the original question itself, you still need to do the right things. The teacher will make sure that marks you correctly as per your answer. So we can, because this cannot be visible by that 3. And remember, we are looking for n, it's a position. It must be a real number, a positive integer, the answer. It must be, your answers, it will be 2 answers, but your position must be a positive integer. In this particular instant, if you divide by a negative 3, well, let's see, it's going to be n squared minus 29 over 3 n. You can't divide by n because that's what we are looking for. Equals to 0. Dividing by minus 3 that side. Such that you'll have that into n minus 29 over 3, factorizing that, equals to 0. So n is 0, or n is actually 29 over 3, but n cannot be that because it's a position. So in this particular instant, n needs to be 0, and the position must not be there. Which I say there's a little bit of a mistake with this question, but you should still be marked right if you did the right thing. And that is that for our lesson today. Thank you so much. Keep on keeping on.